In section 7.2, we will be using the law of sines to solve oblique triangles. We're going to be finding the missing parts of triangles that are not right triangles. These are collectively referred to as oblique triangles. There are a couple of examples. There are acute triangles as well as obtuse triangles. We're going to be able to find all the missing sides and all the missing angles using our law of sines. Now, what this means up here by the law of sines is SAA or ASA. Y'all, that means side angle angle is given. Okay? Two angles are given and the non-included side in between those two angles. Okay? So this side angle angle case would be if you were given, let's say like this angle of a triangle as well as this angle of a triangle, and you were given this length of this non-included side. All right? Whereas this one, you're on angle side angle, you are given an angle, and the side that is included between those two angles. So if you have that case, you might be given this angle and the side in between that. So that is what we call angle side angle case. All right? So for that, we're going to be using the law of sines, okay? If you are given two sides and an angle opposite one of them, the side and non-included angle case, you're going to still use the law of sines. This one, though, is a little tricky. We'll see later on when you're given side, non-included angle. Now, other things that you could be given and you'll be able to solve the triangles are when all three sides are known, side, and also side, angle, side. If that happens for 3 and 4, we're going to be using what we're going to be learning in section 7.3, the law of cosines. So the law of cosines in 7.3. So for today, we're going to be working off of these three cases. So pay attention to this angle, side, angle case, side, angle, or side, angle. Okay? And then there on the tip, it talks about what we just mentioned. ASA means angle, side, angle. Two angles and its included side is what that would mean. Okay? So here is the law of sines. Now, it's expressed as what we call an extended proportion. And what you're going to be using, though, is going to be just two of the three parts, depending on what you're given. So we might just use, say, like this proportion to solve for missing parts. Recall that one thing you need to know is how to set these triangles up. Okay, if we should decide to label this side A, then the angle opposite side A must be angle A. All right? Now, if this is side B, lowercase side B, then the angle opposite that is going to be angle B. All right? Now, finally, side C, which now since we have an oblique triangle is not required to be a right angle, okay? This angle opposite that is going to be angle C. All right? Remember, that's how we need to set these up. So basically, to be able to set up our proportion and enable us to solve the missing parts, we say, I kind of actually like to do like over here. I'll say like the sine of the angle is to side A as the sine of angle B is to sine B. Okay, so you might use that proportion. Or if you're given some stuff about B and C, you might be saying the sine of angle B is to side B as the sine of angle C is to side C. Or if you're given A and C, you could say, for example, that the sine of angle A is to side A as the sine of angle C is to side C. So really, to apply the law of sines, what you really want to do is, what you really need is somehow you need to get a pair. You need to get some kind of side with its opposite angle. And that way, you're going to be able to set up one of those fractions. Okay? Let's just see some examples on how this works. On example 1, it says to solve the triangle for the sides give an approximation to 1 decimal place. What we're going to be doing is we're given that angle A is 27 degrees, angle B is 71 degrees, and side B, which is opposite angle B, is 186. Maybe that's centimeters or miles or whatever it is. Okay? What I like to do is draw just a reference triangle of some sort. Okay? Now, this may or may not be drawn to scale. It's really not a big deal. Let me see. Is there a better, like, I don't know. I'm just going to use, say, like, maybe that one. I don't know. And really, I don't know that I really like for that to be, looking necessarily obtuse like that, because it might not be an obtuse triangle. Let me just draw one. Okay. And I also didn't really want to use, let me show you this. I didn't really want to use this option right here because that's an isosceles triangle. And these might not have two sides that are equivalent. Okay, I'll just old school draw a triangle. Now this won't be drawn to scale necessarily. Okay, but the way I'm going to set this up is I'm going to say angle A is 27 degrees. So if that is angle A, if it's 27 degrees, then opposite that, I need to call that side A. Okay? However you want to assign angle A to be. But now angle B is 71 degrees. Maybe I want to say that's 71 degrees here for angle B. So the side opposite that must be side B, which is 186 units. Okay? Now, let's label what is missing. What is missing and what we are to solve for is side A. I'll put that in blue. Okay? Side C, as well as angle C. I'm just going to call it C, and I'm going to put a little doodah right there. So now when I'm setting up my answer box, those are the amounts that need to go in there. Okay? Side A, side C, and let me go ahead and say angle C. Those are the missing parts. I am defined. Now, here's the thing. We have a angle as well as its opposite side. Okay? So we are able to write the ratio that the sine of 71 degrees, angle B, is to side B, 186, as the sine of another angle is to its side opposite. So what I'm going to use here is I'm going to say the sine of 27 degrees, angle A, is opposite side A. Okay? So I didn't write it out, but what I've got here is the form. The sine of angle B is to side B, and that was given in my information over here, as the sine of angle A is to side A. And angle A was also given here. So now I have this equation that only has one unknown variable A in it. I'm going to be able to solve this equation. Okay, now, there is a little shortcut that you can use when solving proportions. Again, we'd want to clear out these fractions, but the way that we can efficiently do that is to what your high school algebra teacher probably called cross multiply. Now, the reason you can cross multiply is because that in any proportion, the product of the extreme terms, though we call those the extremes, is equal to the product of the means. That's a little theorem when you're dealing with proportions. Okay, now I want to kind of get rid of that because I don't want too much going on there. I'm going to kind of move that out of the way. Maybe I'll erase it. Maybe I won't. I don't know. Okay, but what we are going to do is we are going to cross multiply all of that stuff. Okay, so when I cross multiply, I have A multiplied by the sine of 71 degrees, right? Because I cross multiplied. That's equal to, bring down your equal symbol, 186 times the sine of 27 degrees. Now, before we go punch stuff in, let's go ahead and solve for what we're trying to find, which is side A. So what I'm going to do to solve for A is I'm going to divide both sides by the sine of 71 degrees. And so A is going to be equal to whatever I get on my calculator for 186 times the sine of 27. And then I'm going to divide that by the sine of 71 degrees. Okay, so on my calculator over here, if I can move it around so I can see what I'm supposed to punch in, that would be helpful. Okay, finding side length A. I'm going to have 186 times the sine of 27 degrees. Okay, that's the numerator. Then I'm going to divide that number by the sine of 71 degrees. Now remember, our calculator is probably still set in degrees, but if it's not, you'll definitely want to check that out. And so side length A is the 89.307. It's said to round to one decimal place up here, and so I'm going to say A is 89.3. Okay, so it's 89.3. Let me put that up here in my answer box. 89.3 units, right? Okay, A is 89.3 if we want to label that over here as well. And now, oh, you know what we could have done before we started applying the law of sines? We could have went ahead and got what is the measure of angle C. Remember that the sum of all the angles in a triangle adds up to be 180. So angle A plus angle B plus angle C in any triangle is 180 degrees. All right. Angle A was given to us to be 27 degrees. Angle B was 71 degrees. We don't know what angle C is, but we know all that adds up to be 180. Okay, and so if you want to subtract 27 degrees as well as subtract 71 degrees from both sides, that will leave us with angle C. Scroll a little bit here. There we go. Okay, so angle C is going to be 180 less the other two angles. Okay. So once you crunch all that, 180 minus the 71 and 27 will leave us with 82 degrees. Okay, so angle C is 82 degrees. Let me label that over here as well. Okay, now the last thing we need to do is find the measure of side C. So for side C, we're going to be able to set up another law of sines. Let me come over here. Another law of sines. I'm still going to use the pair that was given to me here. And I'm going to say that the sine of angle B, which is 71 degrees, is to side B, which is 186, as the sine of angle C, I just found that above here, to be 82 degrees, is to side C. Okay, this is going to cut me off in 30 seconds. So we're going to cross multiply. Another trick is to cross multiply there and then divide by this. That's what we ended up doing. We cross multiplied and divided. And so to get C, It's going to be 186 times the sine of 82 degrees divided by the sine of 71.